Hello there, this is Channel Mahendra Popat. We are discussing Geotechnical Engineering, Index Properties, Relationships and Tests, video part 3. In first two videos, we have learned three-phase diagram, two-phase diagrams, as well as fundamental definitions and formulas of index properties. We very well know that index properties are based to understand geotechnical engineering or soil. In today's lecture, let us move to relationships and then numericals. From basic fundamental index properties and their formulas, we can derive by mathematical manipulations, we can derive these relationships. Let us quickly overview the interrelationships between the index properties. This is gamma B bulk unit weight is equal to G plus E into SR. G is specific gravity, E is void ratio, SR is degree of saturation into gamma W unit weight of water upon 1 plus E. Same way gamma D is equal to G into gamma W upon 1 plus E. Same way gamma D is equal to gamma B upon 1 plus W. Gamma D dry unit weight 1 minus Na. Na is here percentage air voids into G into gamma W upon 1 plus W into G. W is here water content and G is specific gravity. Gamma saturated unit weight is equal to G plus E into gamma W upon 1 plus E. Gamma submerged is equal to gamma dash is equal to G minus 1 into gamma W upon 1 plus E. You can screenshot this or you can write down or note down these formulas as well. Let us go further. I have summarized all the formulas from this chapter until now. Whatever we have learned, it is summarized like this. You also can summarize in a paper all the formulas of this chapter. You can screenshot this before calculating the numericals. These are index properties as well as derived formulas as we see in the previous slide. Let us go to one of the derivations. Derive the functional relationship between bulk density, dry density and moisture content. Or we can say derive gamma D is equal to gamma B upon 1 plus W. We know very well that water content W is equal to weight of water upon weight of solids or dry soil. If we add on plus 1 on both the sides, we can get these equations. By mathematical procedure, we can come to W plus 1 is equal to capital W upon WD. Because we know that capital W is equal to weight of water plus weight of dry soil. As we very well remember that air has no weight. So W plus 1 is equal to capital W upon WD. Now if we make WD subject of the equation, it will become like WD is equal to capital W upon W plus 1. Dividing both the sides by volume capital V, we will get WD by capital V is equal to W capital by V upon into W plus 1. So it is proved that gamma D is equal to gamma B upon 1 plus W. Or we can say relationship between bulk density, dry density and moisture content is like this. Let us go to numericals now. Problem 1. The porosity of a soil sample is 35%. Calculate its void ratio, dry density, saturated density and submerged density. Take G is equal to 2.7, specific gravity is given and porosity N is given here. So I suggest you to practice to write given data before solving any of the problems or any numericals. Let us uh, let us find first item, void ratio. We have already discussed the formula E is equal to n upon 1 minus n. N is given as 35%. I will take n as 0.35. So void ratio is coming 0.538. For dry density item number 2, you can use gamma D or gamma dry formula as well as rho D or rho dry formula. Some people, some literature refers gamma and then they will convert to rho, I mean density. So I am going in both ways. Whichever way is suitable to you, you can adopt that. So let us find gamma dry. G into gamma W upon 1 plus E. So G is given here. Gamma W, by default gamma W is taken as 9.81 kilonewton per meter cube. If you are calculating density with the formula of raw dry and G into raw W upon 1 plus E, then raw W value will be 1 gram per centimeter cube. Generally, unit weight of water is taken as 9.81 kilonewton per meter cube and density of water is taken as 1 gram per centimeter cube. So I am putting gamma D formula and the values as per given. So gamma D becomes 17.22 kilonewton per meter cube, but here I am asked to find dry density. It is density, not unit weight. So I'll convert it by dividing raw by dividing 17.22 by 9.81. So it will be converted into gram per centimeter cube and density. So 1.76 gram per centimeter cube is dry density of this particular soil. Gamma saturated because I want saturated density. Same way, I'll find saturated unit weight and then I'll convert it into saturated density by putting the formula G plus E into gamma W upon 1 plus E. We have G, E and gamma W is taken as 9.81 kilonewton per meter cube. So gamma saturated will be 20.65 kilonewton per meter cube. If I want it in gram per centimeter cube, as it is asked as saturated density, I will convert it into gram per centimeter cube by dividing 20.65 by dividing 9.81. So it becomes 2.105 gram per centimeter cube. Quantity number 4, submerged density. So I'll use gamma submerged is equal to G minus 1 gamma W upon 1 plus E. Here G, E and gamma W all are here. So gamma submerged comes as 10.84 kilonewton per meter cube. If I want to convert it into density or gram per centimeter cube, it is 1.10 gram per centimeter cube. So we found all four things. I have calculated unit weight as well as densities because you can you can differentiate between both the quantities as well as you can relate to literature by different authors. Moving forward, next problem, a sample of fully saturated soil has a water content of 34%. The specific gravity of soil is 2.7. Calculate void ratio, dry density and bulk density. So, two things are given and three things are required. Given data, if I write given data, water content is equal to 0.34 or 34 percentage and specific gravity G is equal to 2.7. I want three things. First one is void ratio. I'm putting void ratio formula in that W into G upon SR. I am given fully saturated soil, so SR will be 1 here. W is given, G is given, so I can find void ratio. Void ratio value is 0.918. Item 2, dry density and then bulk density. Again, I am using gamma D formula. You can also use raw D formula. G into gamma W upon 1 plus E. Here we have G, E and gamma W is taken as 9.81 kilonewton per meter cube. So gamma D becomes 13.81 kilonewton per meter cube. If I want to convert it into dry density, I'll divide it by 9.81. Dividing it by 9.81, it becomes 1.4 gram per centimeter cube. And third quantity, bulk density, gamma D is equal to gamma B upon 1 plus W. Here I have gamma D value, I have water content value, so I can find gamma B. For that, I'll make gamma B the subject of the equation and put the values which I have. So gamma B becomes 18.50 kilonewton per meter cube. If I want it in terms of density or gram per centimeter cube, I'll convert this by dividing it 9.81. It becomes 1.89 gram per centimeter cube. So let us move forward. Problem next is suggesting a soil specimen has a water content of 10%, a unit weight of 20 kilonewton per meter cube. The specific gravity of a soil mass is 2.7. Determine dry unit weight, void ratio and degree of saturation. We are provided with three things: water content 10%, bulk unit weight or unit weight 20 kilonewton per meter cube, and specific gravity G is equal to 2.7. Let us find out dry unit weight first. Gamma D is equal to gamma B upon 1 plus W. Again, if you remember the formula, you will easily get the solutions of the problems. So please try and remember the all formulas. Okay, gamma D is equal to gamma B upon 1 plus W. Gamma B is given 20 kilonewton per meter cube. Water content is given as 10% or zero point 0.1. So dry unit weight comes as 18.18 kilonewton per meter cube. Now I want void ratio. For void ratio, I can use gamma D and gamma B both because I do have both the values. Again, I am applying the derived formulas. Gamma D is equal to G into gamma W upon 1 plus E. Here, I do have gamma D now. I have G now. Gamma W is by default 9.81 kilonewton per meter cube. Putting all the values in the formula, I'll get E void ratio as 0.457. If I want to find out degree of saturation, I can use void ratio now. So I am putting E is equal to W into G upon SR. In here, I got E, I have W and G in the problem, so I can find out SR by making it subject. So if I make SR a subject and put all the values, SR value will be 0.5908. So I can tell SR in percentage 59.08 percentage. Let us go further. Sample of sandy soil has 33% of porosity. Find density index if maximum and minimum dry unit weight of sample is respectively 18 kilonewton per meter cube and 14 kilonewton per meter cube. And also specific gravity is 2.6. So we write given data first and then we will solve the problem. So in given data we are provided with N porosity as 0.33, specific gravity G is equal to 2.6, gamma D maximum and gamma D minimum as 18 and 14 respectively. Let us go find out first thing, void ratio, n upon 1 minus n. As we are having n value, we can find out E as 0.492. Now we will go to E minimum and E maximum. For that, we will use gamma D max and gamma D minimum, which is provided. So gamma D max formula will be like G into gamma W upon 1 plus E minimum. Whenever density will be maximum, the void ratio will be minimum. I mean, the soil mass is dense to up to its maximum capacity, then voids will be minimum, void ratio will be minimum there. Uh, Same way, if density is in the loosest state or minimum dry density is, then void ratio will be maximum. Putting the values in this formula, we can get E minimum and E maximum as 0.417 and 0.822. E minimum, E maximum and E values will be helpful to find out density index. So ID density index formula is E max minus E upon E maximum minus E minimum. Putting all the values in ID, we will get 0.8148. So density index in percentage will be 81.48 percentage. I will conclude this video here. From next problem we will discuss in the next video. Thank you.